Okay, so here we're going to look at finding the area of a rectangle, a triangle, and a parallelogram. It's important to remember to state your rule first, followed by your number sentence, then followed by your answer. It's also important to remember to make sure that you're using measurements that are in the same unit. So in this rectangle at the moment, you can see that there are centimetres here and millimetres here. Whenever we're dealing with area, we need to make sure that these are either both centimetres or both millimetres. In other words, we want to make sure they're always in the same units when we use them. Okay, so the area of a rectangle. Now, area is described as the number of squares that fit into a shape. So we know the easiest way, instead of drawing out those squares in this shape, is to use a rule. And we should be familiar that the rule of a rectangle is the area of a rectangle, and we draw a little rectangle there to show that's the shape we're doing, is length times width, where L stands for the length and W stands for the width of the shape. The next step then is to show our number sentence or our working. Now, before we do that, we need to make sure, as I said, that these numbers are in the same units. So 2.1 centimetres can stay, but we could change this information of 16 centimetres, millimetres, we know is 1.6 centimetres. So when we put that in our working over here, we know we're going to use the right units. So the length is 1.6 centimetres, okay, which is the length of the shape, how long it is. And then the width of the shape is 2.1 centimetres. So we write that we're going to do this next. Now we can do some working over here if we need to, because we're not using calculators, but in the bigger years you will be able to use a calculator. But you would still be expected to set out your work like this. So we'll do some working. 1 times 6 is 6. 1 times 1 is 1. Now, with multiplying numbers that have decimal points in them, we put the decimal points in at the end, and I'll show you how you do that. So you just do your normal multiplication as you would do normally. So 1 times 6 is 6, 1 times 1 is 1. We put our 0 down. We look at the tens, the next place, sorry, which is the ones place really. 2 times 6 is 12. And 2 times 1 is 2, plus 1 is 3. Okay, and in any 2-digit by 2-digit multiplication, we then add our answers. 6 and 0 is 6, 1 and 2 is 3, and 3 is 3. So here we look at, in order to know where the decimal point is, we need to look at how many numbers are on the right-hand side of the decimal point. So we have one number here that's on the right-hand side of the decimal point, and we have another number there that is also on the right-hand side of the decimal point. So because there are two numbers on the right-hand side of the decimal point, we bring our decimal point in two places here. And our decimal point goes there. So our answer over here for the area of this shape is 3.36 centimetres squared. Now we can also do this in millimetres squared. It depends on what the question is asking. If it's asking for answers in centimetres squared, leave it in centimetres squared. And if it's asking for millimetres squared, then you need to multiply it into millimetres squared also. Make sure that it's put into millimetres squared. But it's up to you how you do your working there. Okay, and that's it. That would be our answer, which we leave just like that for full marks on a question like that. All right, looking at the area of a triangle now. So looking at the area, we need to know a few things about a triangle. We first of all need to know that there is a base to the triangle, and we need to identify that. We also need to know about perpendicular height. And we need to identify the perpendicular height, which is often indicated by a dotted line between the base and the very tip of the triangle, or a little right angle there. Wherever you see that right angle here, that will be indicating the perpendicular height of a triangle. So this height here is the perpendicular height of this triangle, and the measurement given to that perpendicular height is 27 millimeters, while the measurement given to the base here is 60 millimeters. So even though there are lots of different numbers here and it might be confusing, you need to recognize the base of the triangle as adjacent to the perpendicular height of the triangle. Okay, they will always make a right angle. The base and the perpendicular height will always make a right angle. So even if you've got a different triangle, I wonder if I can, whoop. Even if I can make a different right angle triangle, which I'll try and do here. I'll just have to draw it out. So even a triangle like this, where the right angle is here, the base will be this bottom part here, will be the base, and the perpendicular height will be this height here. So even if there are numbers drawn in, let's say 5 centimeters, now this will be incorrect. That's not correct measurements there, but just for communication, if there are 3 measurements here, then we need to know which one's the perpendicular height and which one's the base, and you need to recognize it by, of course, that little right angle in the corner. Okay, so that's the first thing you need to think about when you come across finding, having to do the area of a triangle. So the first thing then is to know what the rule is for the area of a triangle. Now we know that the rule is going to be the length of the base, or B, times the height, the perpendicular height to be precise, and then we're going to divide that by 2 to get our answer. So we write our rule first. Now there are lots of other ways to write our rule for the area of a triangle. Some people will write it like this. Area of a triangle is half times the base times the perpendicular height. Some people might write it differently again. Divided by 2, but they are all just different ways to express that once we know the measurement of the base, we times it by the height and we divide it by 2. It's the same thing, just a different way of writing out that rule. Okay, but we're going to use this way of writing it for ours. So the base here, we look at the green line, the bottom of the triangle. Okay, sometimes it's not always the bottom of a triangle as well. The base might be this length here, and the perpendicular height might come out of it like this. It's not always going to be set out beautifully like this. The triangle could be turned around a little bit. Let's see if I can turn it around, my triangle. Not quite, but the triangle can be moved around and it will look, the base might be different on different sides. So you've just got to be aware that the base is adjacent to the perpendicular height, so you know which measurements you're using. Okay, so the base is 60 millimeters and the height is 27 millimeters here. And then we're going to multiply them together and then divide it by 2. So notice I still write my number sentence in. The B becomes 60, the perpendicular height becomes 27, and I still write my divided by 2. So then I work that out over here, 60 multiplied by 27, and do some working. 7 times 0 is 0, 7 times 6 is 42, put my 0 down, 2 times 0 is 0, and 2 times 6 is 12. And I add them together, and I get 0 and 0 is 0, 2 and 0 is 2, 4 and 2 is 6, and 1 here is 1. So my answer is 1,620 millimeters squared. Millimeters squared. And that would be it for the area of a triangle. Okay, so moving on to the area of a parallelogram. Now, we're going to use some of that language we used for the area of a triangle. And as you can see, we would use that language because right away in this shape you can see that there is a right angle and there is that height again called the perpendicular height. So we're going to use that language when we do the area of a parallelogram. And we have a base to the shape as well along here. So if I draw those colours again, you can see that here is the base of the shape, which is 2 centimetres. And here is the perpendicular height recognised by that right angle, which I've completely covered at the moment, which is 120 millimetres. So to work this area out, we just need to know our rule, which is very similar to the area of a rectangle, except instead of using length times width, we're going to be talking about it being the base times the height. So the area of a parallelogram equals the base times the perpendicular height. So the base in this shape, now notice the units are different again. We've got millimetres and centimetres. So we need to make sure we turn one of these units into the same as the other. So 120 millimetres is the same as 12 centimetres because there are 10 millimetres in a centimetre. So if there are 120 millimetres, there must be 12 centimetres. Alright, so the base of this shape, we're looking at B here, meaning the base is 2 centimetres. And the perpendicular height is 12 centimetres. So then it's just a matter of timesing them together and making sure we put the squares, the centimetres squared in. So 2 12s are 24, we should know that, centimetres squared. And that one's quite easy to do. So the area of a parallelogram might come in different shapes. So if I look at a few others, you might have it rotated again. Unfortunately, I can't seem to find where I can rotate. Oh, here we go. Rotate 90 degrees. They might rotate. So that shape might rotate again. So you've got to be able to recognize the shape in a different way. So it might look like this. It might come along like this. You've got to recognize again where that base is, and it's always going to be at right angle to that little right angle there and that perpendicular height, okay, which is the height of that parallelogram. It's just been rotated. So you've got to be good at knowing where your base is and your perpendicular height is on all of these shapes to then follow through with the rules. So that's the same with our triangle. Now that I know where the rotational tool is, I can move this out of the way and hopefully give it a bit of rotation. Right, 90 degrees. So again, here's our triangle. And you've got to recognize, okay, it doesn't look like clearly where the base is, but I can see here's my perpendicular height because of the right angle is distinguishing in it. So adjacent to that here must be my base. And the height comes off it in this way, so that must be my height. So you've got to be really good at recognizing those two things when it comes to calculating the areas of these shapes. All right. And that's it.